Hello everyone, Jain to all. Welcome in digital studio of Ajay Kumar Garg Engineering College, Ghaziabad. In this video lecture, I am going to discuss about tree traversal. Before starting the topic, we want to discuss what is mean by tree. Tree is the basic concept which is used for data storing. It is a non-linear data structure in which we have to perform number of operation, and the tree traversal is the one of the operation of tree. Here we have to discuss traversing of binary tree, pre-order traversal, in-order traversal, post-order traversal, and one example on the three traversal. First of all, I want to discuss about the tree traversal. What is mean by traversing of a binary tree? The term tree traversal means traversing or visiting each node of a tree. There is a single way to traverse the linear data structure such as linked list, queue, and stack. Whereas there are multiple ways to traverse a tree that are listed on the next slide. This is the basic concept in which we have to visit each node at once. In case of tree traversal, we have to visit each node by using the operations tree traversing. In this case, we have to discuss about the each node, how the node is visited in case of tree traversal. We have to visit all node in three manner. The first one is pre-order traversal, second one is in-order traversal, and third one is post-order traversal. This is the three way of traversing of a tree. That is also known as type of traversing. In case of pre-order, we have to process the root node first, then process the left subtree, then process the right subtree. But in case of in-order traversal, we have to process first the root, then in case of in-order, we have to process first we have to process left subtree, then right root, then right subtree. In case of post-order traversal, we have to process left subtree, then right subtree, then root. This name is according to traversing of root. Pre-order means we have to process the root first, then left subtree, then right subtree. This is the case of pre-order traversal. In case of pre-order traversal, this technique follow the root left-right policy. It means that first node is visited, after that left subtree is traversed recursively, and finally right subtree is recursively traversed. As the root node is traversed before the left and right subtree is called pre-order traversal. In case of pre-order traversal, we have to process the root first, then we have to process left subtree, then we have to process right subtree. In next slide, we have to take an example. This is an example on a binary tree and how this tree is traversed. We discuss one by one. This is the method to traversing a tree. This is a binary tree because each node have at most two child, so that this tree is called a binary tree. Because A is a root node and a root node having only one child, so we have to call it a binary tree. B is a next node which have also two child, D and E. It is also follow the condition of binary tree. And C is the next child which have also two child. F is the left child and G is the right child. So that this tree is called a binary tree. And how the binary tree is traversed by using pre-order traversal. We have to take a condition like this. First, we have to traverse root, then left subtree, then right. That means we start with root. and process the root. A is the root, so we have to process A first. And we have written like here, A is the root, so we have to process A, and we have write here A. Now, process the left subtree in the similar manner. The left subtree is, start with B. B is the root of left subtree, so we have to process next B. So after A, we have to process B. Now, go on the left subtree of B, and the left subtree of B is D. So we have to process again D, and we have right here D. Now, after processing the left subtree, we have to move on right subtree because root is already processed in case of pre-order traversing. Now we move on E. E is the right child of B, so we have to process E after D. Now move on the parent of E, and E has parent is B, and B is already processed. Move on parent of B, that is A. A is the root of the given tree, and A is already processed. Now move on the right subtree of A. The right of subtree of A is start with C, and C, the left child of C is F. We have to process first C, then move on F. F have no child, that means F is processed after C. Then there is no left or right child of F, so we have to move on root. After moving the root, we have to find the right subtree of that node, and the right subtree of C is G. Now we have to process G. This is the sequence of traversing a tree in a pre-order traversal. This is the sequence we have to written here. First, we have to process A, then B, then D, then E, then C, F, and G. This is the sequence of traversing a binary tree by using pre-order traversing algorithm. Now, the next point is post-order traversing. In case of post-order traversing, we have to process left subtree, then right subtree. After that, we have to process root. That means root process at the last of the traversing. First, we have to process left subtree, then right subtree, then root. This is the sequence which is followed in the case of post-order traversing. That means the post-order traversal means the root is traversed at the last of the processing the left and right subtree. This technique follow the left-right rule. That means first we have to process left, then right. After that, we have to process root policy. It means that the first left subtree of the root node is traversed. After that, recursively traverse the right subtree, and finally the root node is traversed. As discussed before, first we have to traverse left subtree, then right subtree, and at last we have to process root of the given tree. As the root node is traversed after the left and right subtree, so it is called a post-order traversal, because the name of the traversing algorithm is decided on the basis of traversing condition of root node. In pre-order, we have to process root first, but in case of post-order, we have to process root at last. That means first we have to process left subtree, then right subtree, and then we have to process root node. This is an example on post-order traversal. This is also a binary tree, same binary tree which is discussed in pre-order. We want to process this tree by using post-order traversal. In case of post-order, we have discussed earlier, first we have to process left subtree, then right subtree, and then root. In the given tree, A is the root node, B is the left subtree of root node A, and C is the right subtree of root node A. After subtree, in processing subtree, B is the root node of subtree D, and B is the also root node of subtree A. In case of right subtree, F is the left subtree of C and G is the right subtree of C. First, we have to process left subtree. Starting with root node, we move on left subtree. Now, B is also a root, so we move on left subtree. We don't process the B before processing his left subtree. We goes on left subtree, and that is D. D has no left child or right child, so we have to process D first, and we have to write here D. After processing the D, we move on parent of D, that is root of D, and the root of D is B. Before processing the B, we have to move on right child of B, and the right child of B is E. We have to process E after processing the D, because in case of post order, first we have to process left subchild, then right subtree or right subchild. After that, we have to process root. After processing B, D and E, now we have to process B. After E, we have to process B. Now, move on the parent of B, and that is A. A is the root. We process all the left subtree of A, so that now we have to move on the right subtree of A. And the right subtree of A start with C. C is the node, or C is a subtree, which left child is F and the right child is G. Now, we have to move on the left child of C. According to condition, first we have to process left. So that we have to move on left child of C, and the left child of C is F. We have to process F. Then move the left or right subtree of F. Here there is no left tree, so we can't move on left. And there is no right, so we can't move on right child. Now move on parent of F, that is C, and the right child of C is G, so we have to move on G, and G has no left child or right child, so we have to process G. After processing F, we have to process G. If there is a right child, then after processing G, we have to process the right child of G. But here there is no left or right child of G, so that we have to process G. Now move on the parent of G, and the parent of G is C. After processing the left child of C, F, and right child of C is G, we have to process C. After G, we have to process C. Now move on the root of C. The root of C is A, and the left child of A is already processed, and the right subtree of A is also already processed. Then we have to process now A. This is the sequence of processing of this binary tree by using post order traversing. This is the sequence which is written on the top. This sequence is same, because this sequence also by using post order traversing, and we have to write here by using post order traversing. So this is the similar to left subtree traversing, right subtree, then we have to traverse root of the given tree. Now the next traversing algorithm is in order traversing. In case of in order traversing, first we have to traverse left subtree, then root, then we have to traverse right subtree. Here the root is traverses in between the left subtree and right subtree. This technique follow the left, root, right. This is the keywords. Left, then root. First we have to traverse left, then root, then right. Policy. It means that first left subtree is visited, after that node is traversed, and finally the right subtree is traversed. As the root node is traversed between the left and right subtree, it named in order traversal. As you discussed earlier, the name of the algorithm is decided according the position of a root of the position of the root. Here the position of the root is in between the left and right subtree, so it is called in order traversing. In post order traversing, first we have to traverse left subtree, then right, then root, that traversing algorithm is called post order traversing. Now this is our example which is on which we want to show how the in order traversing is worked. This is also a binary tree, and same binary tree which is discussed in previous slides. Here A is the root node, B is the left subtree, and C is the right subtree. First, we have to recall the algorithm in order traversal. In case of in order traversal, first we have to traverse left subtree, then root, then right subtree. Now A is the root. Find out what is the left subtree of A, and that is B. But B is the also root for the child D and E. So we move on the left subtree, and the left subtree is D. This is the left subtree of B, and D has no left child or right child. So we have to process first D. We have to write here D. Now we have to process the root of the D, and the root of the D is B. So we have to process B before processing the right child of B. After processing the B, we have to process the right child of B, and the right child of B is E. Now we have to process E. The left subtree including B is processed. So we have to move on root of the left subtree, and the root of the left subtree is A. Now process the root A. Okay. Now we have to move on the right subtree of A, and the right subtree of A is C. And C has two child. F is the left child and G is the right child. We have moved on the left child of C, and the left child of C is F. And there is no left or right child of F, so we have to process F, because we have to using in order traversing algorithm. After processing F, we have to move on parent of F, that means root of F, and the root of F is C. Now we have to process C. After processing C, we have to move on right child of C, and the right child of C is G. That is processed now. After processing the G, the right subtree is processed. And this is the sequence of processing or traversing the given tree. This sequence is same as which is written on the bottom. First, we have to process D, then B, then E, then A, then F, then C, then G. This is the sequence of traversing a binary tree. And this is the last method and last algo to traverse a binary tree. This is the basic question of data structure, in which basic question of data structure are as you can say this is the basic question of tree, and this part is considered in the topic types of operation, and traversing is the first operation of a binary tree, in which we have to use three basics operation of traversing. First, pre-order, second, post-order, and third one is in order. By using these three techniques, we have to traverse a given tree according discussed in the given question. This is an example. In this example, we want to find out the tree traversal. That means we want to find pre-order traversal, post-order traversal, and in-order traversal. First, we want to solve this question by using pre-order traversing. First, we want to discuss this is a tree. This tree is binary or something other. This tree is a binary tree because each node having at most 2 child. So that this tree is a binary tree. We want to traverse this tree by using the traversing algorithm, and the first algorithm is pre-order. In case of pre-order, first we have to traverse root, then left, then right. This is the method which is used to traverse in case of pre-order traversing. First we have to traverse root, then left subtree, then right subtree. Here f is the root, so we have to traverse f because f is the root. After traversing the f, we have to move on left subtree, and the left subtree is b. So that first we have to traverse b because b is the root of left subtree of f. Now, after traversing the b, we have to move on left subtree of b, and the left subtree of b is a. So, we have to traverse a. After traversing a, we have to check there is a left child or right child of a. No, there is no left or right child of a. So, now we have to move on the parent of a, and the parent of a is b, which is already processed. Now, move on the right subtree of b, and the right subtree of b is d, c, and e. D is the root of right subtree of b, so that we have to process d. After processing d, we have to move on left subtree, and the left subtree is c, which is a single node, and we have to process c. After processing c, we have to check there is a left or right child of c. No, there is no left or right child of c. So, we move on the parent of c, that is d, already processed. Now, the right child of d is e. Now, processed e because we have using root, left, right, so that we have to process e. After processing this node, the left subtree of f is processed. Now, move on f. F is already processed because f is the root, and root is processed starting at the tree because this is the root, left, right concepts. Now, move on right subtree of f, and the right subtree of f is g, and g is the root, so that we have to process g. After processing the g, we have checked there is a left child of g. No, so that we have to move on right subtree of g, and the right subtree of g is I. We have to process I. After processing the I, we have to move on left subtree of I, and that is h. H is processed. After processing h, we have to move on left or right child of h, but there is no left or right child of h. Move on the parent of h, that is I. There is no right child of I, so we have to move on back to the g, then back to the f. These nodes are already processed, so that this is the pre-order traversing sequence of the given tree. Now, we want to process this tree by using post-order traversal. In case of post-order traversal, first we have to process left subtree, then right subtree, then root. Left subtree, then right subtree, then root. This is the sequence of traversing by using post-order traversal. First, we have to traverse left subtree. We start with root. Root is f. Move on left subtree, that is b. This is also root. Move on left subtree, that is a. We process the a first, so that here we have to write A, because left, right, then root will be processed. After processing the left, we have to move on right subtree of B, that is D. That after moving on D, we have to move on left subtree of C, and that D, that is C, we have to process C. After processing the C, we have to move on right subtree of D, and that is E, we have to process E. After processing E, we have to move on parent of E, and the parent of E is D, so we have to process D. After processing D, now move on the parent of D, that is B, we have to process B. Now, after processing B, we have to move on root of B, and that is F, we have to process F. After processing F, now we have to move on right child of F, and the right child of F is G. There is no left child, so we can't move on left. There is a right child I, we move on I. There is a left child of I is H, we have to process H. Then right child of I, there is no right child of I, so we have to process I. Then we have to process G, then we have to process A. This is the sequence of post order traversing. Now, the same question we want to process with by using in order traversing. In case of in order traversing, first we have to process left subtree, then root, then right subtree. This is the sequence which is follow in case of in order traversing. Now, this is the root. First we have to move on left subtree. This is also root. Now move on left subtree. We process A. After processing A, here we want to change. Here the F is processed at the last. In case of post order, this is the F, so that we have to write at last is F. In case of in order, first we have to traverse A. After processing A, we have to move on the root, and the root is B, so that we have to process B. Then move on right child is D, and the right child D have left child C, so we have to process C before processing the D. After C, we have to process D. Then the right child of D is E. After processing E, we have to move on parent B. B is already processed. Then move on F. F is processed now because the left child of F is processed, so that we have to process F now. After processing F, we have to move on right subtree, and the right subtree is G. G has no left child, so we have to process G directly, because after processing left, we have to process root, then right. There is no left child, so we have to process G. After processing G, we have to move on I. I have one left child, that is H. We have to process H after processing G. Then move on root, and root is I. I is processed. After processing I, we move on right child. There is no right child, and this is the final traversing sequence in case of in order. This is the all about tree traversal. If any doubts or any inquiry, please comment in the comment box. Thank you. Thank you so much.